Welcome to Module 203C on Basic Gas-Fired Forced Air Heating Systems. We're going to look at objective number 2 now, which is to take a closer look at what thermocouples are. We've already discussed a little bit about what their job is, which is as a flame-proofing device inside our systems, and they control the gas valves in order to shut the gas off in case we lose our flame. We're going to take a closer look at how exactly we make sure that this thermocouple is operating properly. There are a number of different tests that we do to make sure that our thermocouple is operating correctly. The first thing we need to make sure of is that it is placed right. We need to make sure that thermocouple is sitting inside the flame of the pilot light. The first test we're going to do is called the open circuit test, where we take our millivoltmeter and attach it to the two leads that are coming out at the end of the thermocouple. We should be reading a voltage between 26 and 32 millivolts. If we are not reading this voltage and our voltage is too low, we have to try to reposition the thermocouple until it is reading that 26 to 32 millivolts. If you still cannot get that voltage, we might have to talk to a gas fitter to increase the flame in order to achieve this value. After we're done with the open circuit test, we want to do a closed circuit test, which means now we're going to install the thermocouple into the gas valve itself. In order to make this test work, we need to make sure we use an adapter, such as you see on the screen. When we have the valve operating and working off the voltage of the thermocouple, what we're going to see is a massive voltage drop inside the actual valve itself. So therefore, my closed circuit test should be approximately 25 to 50% of what the open circuit voltage is. So if I read 30 millivolts, I should be sitting anywhere between 7.5 and 15 millivolts. The third test that we do is called the response time test, and this test tells us how long it's going to take the thermocouple to drop below a voltage level where it's going to allow the gas valve to close. In order to do this test, we need to allow the pilot and the main burner to get to a normal operating temperature. Then we turn off the main gas valve and we blow out the pilot light. Watch the voltage meter as the voltage levels drop. We will see a point where the needle is going to jump, or the numbers are going to jump up instead of going down. At this point, the solenoid has dropped out, and we might even hear a click at the same time. The voltage at this point is called the dropout voltage. The dropout voltage is used in the last test, which is called the turndown test, and the turndown test is typically performed by the gas fitter. What the gas fitter does is they wish to turn down the pilot light to its lowest possible level, so it is just above the dropout voltage, and then they see if that's enough flame in order to light the main burner. If it's not, then they'll increase the flame until it's just enough and they're not using any more gas than absolutely necessary. Thermocouples have a very important role to play in our basic furnaces. They are reliable, they're durable, and they provide a very low-cost solution for flame proofing. However, we should also be aware that some of the disadvantages of using a thermocouple is that they do have a slow response. So opening and closing that valve requires them to cool off or heat up, which will take time. They also have a poor accuracy. If we wish to dial in on one specific number, it's going to be a lot harder to do that with a thermocouple. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.